Greetings, fellow scholars. Welcome to your Module 3 Excel report. How exciting, the last module of the semester. So that means we only have 5 weeks left. Unbelievable, time goes by so fast. Well, as always, I'm here to make math count for you. So we're going to start off by talking about our Module 3 Excel report for scenario number 1. We are going to discuss theoretical and empirical probability. We are going to define theoretical probability and odds, and then we're going to simulate some experimental outcomes using applets and spreadsheets, and then compare theoretical and empirical probability, which are going to find out that empirical probability just means to do some experiments. All right, so a typical way to talk about theoretical and empirical probability is to talk about the rolling of dice. When we talk about dice, I want you to notice that we have a cube, so just assume that this is a single cube, and what we're looking at here is all 6 faces. So we have what we call a 1-to-1 correspondence between the number of faces on the dice. The die. Don't forget, this is just one die. It's just all 6 perspectives. So we have one die, and then each face has one integer. So there's a 1-to-1 correspondence between the integers 1 through 6 and the faces of the die. So we have 1, 2, 3, 4, 5, 6, which means that I have a probability of any one of these numbers rolling. So the probability of rolling a 1 is 1 out of 6. So I'm always looking at how many out of the total number. In this case, I want to know the probability of rolling a 6. Well, the probability of rolling a 6 is 1/6. We call that theoretical probability. Mathematically, there are 6 possible outcomes and only one of them could be a 6. Well, here we have any possible outcome for a single number. There are no repeating numbers on this die, so that means that there is a 1/6 probability for any of those integers to end up face up. All right, so when we talk about theoretical probability or probability, we're always listing the total number of possible outcomes in the denominator. So in this case, if you roll the die, we have any one of 6 outcomes can land facing upward. And in the case that we only want a 6, well, there's only 1/6 in all of them. So the number for the numerator is just going to be 1. All right, so the denominator lists the total outcomes, the numerator lists the number of outcomes that we want. So let's look at what happens if I want something different. You know, which we all want something different. That's what improving is, right? Wanting something different. And hopefully we're all working toward improvement. So here I have a 1/6 probability of any of these numbers occurring. Well, what if I wanted to know the probability of an even number occurring? So this P of 1, I'm going to change this to P of even. And how many even numbers do I have? Well, 2, 4, and 6 are all even numbers. So now my numerator says that I have 3 out of 6. What about the next one? What if I wanted to know the probability of an odd number occurring? You know, rolling the die, an odd number rolls on the top. Well, odd would be 1, 3, or 5. Well, again, we have 1/2. And we know, hopefully, that evens and odds are what we call mutually exclusive. There are no even numbers that are odd numbers. Venn diagram, 2 completely different circles. All right, here's one. I just thought of this. How about this one could be a Venn diagram? I wish I would have made a slide to show you. The probability of prime. So if I want to know the probability of a prime number, well, what are primes? 2, what is a prime? A number that is only divisible by 1 and itself. So 2 is composite because you can do 2 times 2. 6 is composite because you can do 2 times 3. 3, 2, and 5 can only be multiplied by 1 to get to get the number back. So 3 times 1, 2 times 1, 5 times 1. Now 1 is tricky. Some people think 1 is prime, but it's not. 1 is a special number. It's divisible by 1, period. Because you can't say 1 and itself because that's the same number. So prime, how many primes do we have here? We had 3 primes. Now, why did I say this Venn diagram would have been good? Because if you had even and prime, we have another special number there, and it's the fact that the only even prime number is 2. So if we had a Venn diagram between evens and primes, we would have to have that overlap where the 2 went into the middle there. All right, let's move on. So here now, let's talk about the theoretical probability of not rolling a 6. Well, if I don't want to roll a 6, that means that all of the favorable outcomes, the outcomes I'm looking for, are here painted in green. So I have 1, 2, 3, 4, 5 outcomes that are not 6. So I have 5 sixths. And then you can see here, if I have it for any of the numbers, again, the probability of not rolling a 1, the probability of not rolling a 2, and so on. All right, so in theoretical probability, in all probability, we know that the denominator is the total number of outcomes, and the numerator is the listed number of outcomes. And I say all probability at the level that we're discussing all probability. There are probabilities where we consider a sample, the probability of a sample in a population, and that can do some different things to our denominator. But we're not going to talk about that in this section here. So here we have our 5 possible outcomes, listed outcomes, possible outcomes. All right, so the probability of not rolling a 6 is 5 sixths. All right, let's look at something different here. So here you see the difference between this and the last pictures we were looking at. This one has some numbers painted red. Well, now I'm going to talk to you about odds. Instead of probability, we're going to talk about odds. What are the odds of rolling a 6? Well, when we do odds, we count our favorable outcomes, stays the same, but our total outcomes, we take not the total of all the outcomes, but just the total of what's left over from what we listed. So the denominator is going to be the total outcomes minus what was listed. So in this case, I have my odds are 1 in 5. And you can often see odds written this way, 1 in 5. And you guys can think about sports teams. You'll see their stats listed 7 to 3. That means they won 7, lost 3, played a total of 10 games. So odds work like that. All right, let's look here. The theoretical probability of rolling a factor of 20 on this 20-gon. So here, look, factors of 20 are going to be 1, 2, 4, 5, 10, and 20. All of these numbers divide 20 evenly. So we have 1, 2, 3, 4, 5, 6 favorable outcomes. So the probability of rolling a factor of 20 is 6 out of 20. And then we reduce that fraction to 3/10, which can reduce to the decimal value of 0.3 and gives us a probability of 30%. Now, when you guys do your Excel report, you are going to be reporting your probabilities as an original fraction, a reduced fraction, a decimal, and a percentage. So now what about the odds of rolling a factor of 20? The odds of rolling a factor of 20, well, we have 6 favorable outcomes and 14 leftover outcomes. So the odds of rolling a factor of 20 are 6 and 14. All right, guys, empirical probability. Let's go ahead and have a quick look at this link here and see if we can make this work. I'm going to pause the video and make it work. Actually, I remembered that I wanted to access this link by going to your spreadsheet. So that's why I undid the hyperlink on that one. All right, so here we are going to go to your spreadsheet for scenario number 1. And then you see right here where it says applet at the bottom of page 1, you're just going to click on that where it says applet, and then it will open up for you. And when it does, we're going to get to do an experiment. So now, instead of doing the theoretical probability and mathematically deciding the probability of rolling a particular number, now we can actually simulate an experiment. So here, this is going to give me the dice. I'm going to roll the dice. Here you can see I just clicked on 1. I don't know, can I make this bigger? All right, cool. All right, so I just clicked on 1 and it rolled a 2 and a 5. And now, and what this is rolling, you guys, is instead of an individual number, it's rolling the sum of the 2 dice. So now I've got 2 dice and this is giving me the sum. So I just rolled again. It's not really working that good when I make it big. And I just keep rolling 1 at a time. Now I rolled a 3 and a 5. Now I'm going to roll 10 at a time. See that? Now watch if I roll 100 at a time. And what happens when I roll 10,000? Look at that. Does that distribution look familiar? So we are actually going to use Excel to simulate some of our own empirical experiments. We're going to demonstrate theoretical and empirical probability using spreadsheets. So let's go have some fun. See you guys on Excel. All right, you guys ready to hop into your Excel report? Before we get to the Excel report, I just wanted to roll back to this slide real quick and make sure you guys know that where this says the probability of 2, it was supposed to say the probability of 1, and then this was supposed to be 3, but what happened was I had cut and paste, so it got messed up. So I didn't want you guys to think that this should be notated differently, and editing the video to put a text in there to tell you that was a little complicated. And then also, just real quick, there was just one other piece where I had actually said that 2, I think something on one of these slides, I said 2 was a composite number. 2 times 2 is 4. So a couple little verbal errors I wish I could have corrected on that if you noticed. If you didn't notice, it's all good. All right, so right here on our Excel portion of scenario 1 for week 12, first I want to tell you guys, bravo, you have done an exceptionally fantastic job of keeping your videos super professional with your business casual, your background, your lighting. Your guys' stuff is definitely portfolio worthy. Beautiful reports. Wow, seriously. All right, so we are going to study theoretical probability. We're going to do some experiments for empirical probability and calculate some odds in favor and odds against. So starting off with our theoretical probability, we see that the instructions tell us to create a table to show the sums of 2 dice being rolled and to create a table to show the products of 2 dice being rolled. So let's go ahead and roll right into that one. I am going to make this a little smaller. Here's our Excel report. I've already gone ahead and got some stuff set up. Ignore that blue chart over there for now. And just go ahead and get this stuff set up. Okay, so you can pause the video, and set this up. I'm going to go ahead and just start working. So here, actually, I'm going to explain to you that when we talk about, I'm using some mathematical notation here, and you can see that back on the document that I did list the mathematical notation down here at the bottom. Thank you, Abaza. I'm almost 100% sure Abaza is the one who taught me that. Others of you may have told me, but I think she was first, which I really appreciate. The character codes actually have number values. So when you guys are inserting your mathematical notation, you are going to go to insert symbols on the far right hand side. I'm using my finger, but you can't see, so I should use the mouse. You go to your symbols here, and then go to symbol, and then right down here under character code, you can actually just type in the code. Here's the one for the product, and here you see it's 03 alpha O, 0, 03 alpha 0, and you guys can find the correct notation that way. So yay for that little piece of advice. I love how much stuff I get to learn every semester from you guys. All right, so here's my chart. I am going to show you the possible outcomes of rolling 2 dice and what all of the sums will be. So you see the top row is the 1 dice. I could roll 1, 2, 3, 4, 5, 6, and then that column coming down the far left is the possibilities of the 2nd dice. And I want to add these together. So I'm going to put an equal sign, and I'm going to add 1 plus 1. You see how I chose the cells? Now I'm going to lock in my Foxtrot 10 by putting a $ around each side of Foxtrot. Now that cell is locked in. Now all I have to do is simply click this and it will fill in all the way down. 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, and so on. All right, now let's take this. If you guys accidentally double click in there, remember the best way out is to just press enter. Otherwise you could get it changing all kinds of values. All right, so now I'm just going to drag this cell all the way over, but stuff's gonna happen because you see this is locked into Foxtrot, but now I want it to be for golf. So you don't even have to make it capital. You can just type that G in there and it will change it to golf. And then you see my Foxtrot 11 here. I want that to be Echo 11. Hit enter. All right, same thing here. Instead of Foxtrot, I want this to be hotel now. And again, I want my golf to be Echo. Take it all the way down. I'm ready to change Foxtrot here to India. And my hotel gets changed to back to Echo. And then again, Foxtrot here goes to Juliet and my India to Echo. And then for the last one, my Foxtrot goes to Kilo and my Juliet goes to Echo. Now, you see how I didn't change these 3? I'm just going to select them all at once. And then, and you know, I click, select, unclick, and then I get my cursor to the bottom right-hand corner, double click, and it fills everything in for me. And I'm just going to kind of go through and check 12. 6 plus 6 is 12. 3 plus 4 is 7. 1 plus 2 is 3. So I just kind of went through and checked randomly. Well, I'm a human. It's really hard for humans to be random. And besides that, what did I even do? I chose the bottom corner, the middle, and then up toward the top corner. It's not even hardly random. All right, let's move along. Now I need to create my next chart for products. So I'm going to select all of these products, Control Copy, and then paste them all in here and Control Victor. All right, let's see what all stuff I have going on here. You see my locked cell? Yes, ideally, I would like to have, instead of this Foxtrot 10 all the way up here on this one, I would rather have Foxtrot 18. But honestly, you guys, does it matter? Because Foxtrot 18, and you know, you guys could have, yours may be in Papa 27 or, you know, Golf 32. You don't have to have your cells the same as mine. But in this case, you can notice that Foxtrot 18 is the same thing as Foxtrot 10. So it really doesn't matter if that changes. And my proximity to the selected one is in the same place. So what does have to be different here? This plus sign needs to be a multiplication. And then I just go all the way down. And now I should be able to do that all the way across, just change my plus to multiplication. And I'm going to come back and do all of these at once. And as I'm clicking on them, I'm making sure that that second number is in the right place all the way back over to my Echo column. You see that? And there we go. Now I just select all of these, that row, and double click, and voila. Let's see if I can randomly choose. Can you close your eyes and randomly choose? I don't know, let's see. right here. 4 times 2 is 8. 6 times 5 is 30. All right, so my random sample, as random as a human can be, has decided that that my sample says yes, all of my numbers are correct. All right, what is next on our to-do list over here? The next piece of this puzzle is to, let's see, we finished that. We created a table to show the sums, we created a table to show the products, and now we are going to duplicate each table and label the tables and highlight the cells accordingly. All right, so let's go ahead and first just duplicate our tables. So I'm just made it smaller to make it easier for me to copy everything. So I'm Control Copy, come over right next door. You guys can see I already did this to practice. Control Victor. All right, now it says to label and highlight accordingly. So we want to label and highlight that the sum is an even number. Make this smaller so you can see. The sum is an even number. The product is a prime number. The sum is a multiple of 3 and a product of 12. All right, so we are going to go ahead and label these things accordingly. First of all, it said the sum of an even number. Well, guys, what is an even number? Well, choose a number, any number. Number 3. 3 times 2 is 6. So what about 5 times 2? 5 times 2 is 10. 2 times 2 is 4. 6 times 2 is 12. No matter what number I multiply by 2, it gives me an even number. So in mathematics, we say that the sum, and here you guys see this sigma value is the same thing as the symbol that I have over here. Whoops, let me go back here to home, auto edit. So you see that big sigma, that means add stuff together. I meant to actually tell you that earlier. That sigma means add stuff together, and then our pi symbol down here means to multiply stuff together. So the sigma, we want the sum, that means the sum of an even number. So 2 times any number, and that's how I notate 2 times any number means an even number. And then this one was going to be the product of a prime. I'm going to select just the word prime here and see, oh, cool. I can make just the word prime smaller. I think that's a new, I don't know if that's new. I don't ever remember that before. All right, so the product of the prime. And then my next chart was the sum of a multiple of 3. Well, any number times 3 is a multiple of 3, so this is going to be 3n. And then down here we had the product of 12. And it's not the product of a multiple of 12 or a product of a factor of 12, it's just the product of 12. So now I have labeled each of my charts accordingly. And now I am going to highlight accordingly. So to highlight this, I know I need even numbers. So I'm just going to hold down the control key here on my keyboard and use my mouse and click all of my even numbers. So I'm just going through. If I miss any, folks, like if I don't get one of the 8s, then please don't get very, very confused. Just know, oh, Miss Binsey missed that 8. Okay? So always be alert to errors that I can make. And don't let it make you very, very confused. All right, so now I am going to paint these little guys, maybe a nice, I don't know, blue? Sounds good. All right, now, did I miss a couple evens? Yep, you see I did. All right, now I am going to come over here to the right and do all of my sums that are multiples of 3. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. And what's left? 3 times 4. All right, so everywhere that I did 3 times a number other than 1. So let's see, I think I have some errors. Did we take a random sample of the products to make sure that they were correct? Oh, I'm still dealing with sums here, sorry. All right, so yes, here we have our sums of 3. Sorry, I was thinking we're dealing with products here. I'm going to paint all of those a nice green and peach, kind of history there. All right, now we're looking for the product of primes. Is 1 a prime? No, it's not, but 2 is a prime. 3s are prime. What else is prime? 5s are prime. Now, are there any other prime numbers on this chart? No. Do you know why there are no other prime numbers? Well, think about the numbers that we have here, 2, 3, 5. Those are each prime numbers on their own multiplied by 1. So this is 2 times 1, 3 times 1, 5 times 1. All of the other numbers in this chart are composite. They all took 2 different numbers besides 1 multiplied together to get them. So there are clearly going to be no other prime numbers within the chart. All right, now we want a product of 12. Well, that's easy because it's just anything that turned out to be 12. Something times something equals 12. There we go. I actually do remember doing that random sample now for the products. Okay, this is going to get painted, I don't know. Oh, how about that? Sunset? Doesn't that look good? Oh, I like that rusty color. I don't know. All right, so here now we have all of our charts. Now I have gone and already created this other chart here. And you guys can create this. I'm going to actually pull this down. I think it might be a little easier to work with if it was down here. Whoops. So you guys go ahead and pause the video. Wow, come on. Oh, I'm not selecting it properly. I didn't have my weather vane cursor. All right, there. You guys can go ahead and pause the video and set up that little chart here. This little chart right there. Okay. And of course, I want borders on my chart. I must have changed my borders. All right, and then I am going to make this a little bit wider. All right, very nice. All right, so you guys have gotten your page there, your table all set up. So let's now go back and see about filling this in. All right, now for the odds, remember you guys, remember our PowerPoint slide. The odds are whatever we want on top and whatever we don't want on bottom. So the odds of rolling an even number, if you count up all of these, you end up with what? 18 over 18. 18 blues and 18 whites. So I'm going to use a little apostrophe here so that it does, so otherwise Excel is going to reduce my fraction to 1. When I put in 18 over 18, and I don't want Excel to reduce my fraction to 1 because that doesn't tell me anything about my data set. If I reduce the fraction in my odds, I don't actually know how many outcomes happened that I wanted and how many I didn't want. So here I know it's half and half. And from that half and half, it's 18 favorable and 18 unfavorable. All right, so what are the odds against? Well, it's the same thing. So I can actually just copy this one. What about the probability? Well, the probability of rolling a 2 is going to be 18. And again, I'm using my apostrophe because I don't want Excel to reduce this fraction. my probability is going to be 18 over what? My total number. Remember, odds give you what you want over what you don't want, and probability gives you what you want over everything. All right, now for my reduced fraction, I can actually just copy this fraction and put it right here into reduced fraction, hit enter, and I need to get rid of that apostrophe. And once I do, it will reduce my fraction. Now, if you did not get a fraction there, then what you should do, well, let me just show you what happens if you did not get a fraction. It would give you a decimal. So you are going to just, go back up here and change it to fraction. But wait, don't even bother with that yet, because look at this. Once we get done with this chart, my reduced fraction right here, which is 1/2, my decimal to the thousandths place, and my percentage are all going to be the same. So these are all the same numbers, just reported in different ways. And if you do remember back on the PowerPoint slide, when we reported our probability here, remember we reported the probability as a fraction, 6 over 20, a reduced fraction, a decimal, and then our percentage. So all of those values are equal. You see the equal sign there? So I'm just going to leave them for now, because I can do a lot more copy and paste stuff and then come back at the very end and change them. So you'll see how that's going to roll out. All right, let's check our primes here. What about the product of a prime? That's my peacock blue here. So, and I know all of these are out of 36 outcomes, because, well, 6 times 6 gives me 36 cells here. So for the product of a prime, I have 1, 2, 3, 4, 5, 6. The odds of rolling a prime are 6 out of what? Well, 36 minus 6. So out of 30. So that means the odds against rolling a prime, that means my favorable outcome is not rolling a prime. The odds against rolling a prime are just the reciprocal of that, 30 over 6. Literally just the reciprocal means to turn it upside down. All right, and then I guess I'm just curious about this cell. Oh, there we go. All right, so now here, again, the probability is going to be, well, the probability of rolling an even, I'm sorry, what are we doing here? The probability of rolling a prime is 6 out of everything, 36, because probability means out of the total full. And I used quotes instead of a, oh, there we go. All right, and then as a reduced fraction, now this time I do not have to put my little thing. I do 6 divided by 36 apostrophe. I don't need my apostrophe this time because I don't mind for Excel to just do whatever it wants to do, which in this case, it's going to give me a date. That's absolutely not what I want. So I am just going to, well, what I can do here is just select all of these cells and take it to, say, fraction. I'm going to come back to this one because it gets confused when you do that. It takes that date and does all kinds of crazy stuff with it. So that's 6 out of 36, right? And it reduced it to 1/6, which is exactly what it should have done. And then now I'm just going to select that cell and control copy and control Victor, control Victor. All right, now, and I'm going to change all of these decimals and percents at the end. All right, now I'm dealing with the odds of rolling a multiple of 3. Well, how many multiples of 3 did I have? Well, could it be about a third? I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 36. Multiples of 3 I have 12 out of 36, but this first column is odds. So that's 12 out of what? 24. And then the odds of not rolling a multiple of 3 are just the opposite of that. And that's going to be 24 out of 12. I'm sorry, 24 to 12. Probability we can say out of, but odds we have to say like 24 to 12 because it's not out of 12. Well, we can't get 24 out of 12, can we? Well, we could get 24 inches out of 12 feet, right? That's just a fun fact too. When somebody says 1 + 1 is 2, you could say, oh, no, 1 + 1 is 13. Because if you have 1 foot and 12 inches, if you have 1 foot and 1 inch, that's 13 inches, right? So 1 + 1 is 13. All right, let's keep moving along here. So now I want to know the probability of rolling this. So I'm going to use my apostrophe again, and I have 12 multiples of 3 out of 36 possible rolls. Looks like I forgot my division sign. All right, and then for the next piece, I'm just going to copy that. It's it. All right, and what about the probability of rolling a multiple of 12? Well, there were only 4 of those. So in this case, I had 4 to 32, right? The odds against rolling a multiple of 12 are 32 to 4. And you guys got to make sure, you have to make sure you have that little apostrophe in there. All right, so now the probability of rolling a 12 is going to be 4 out of 36. And then the reduced fraction of that is going to be 1/9. Now I am going to, I just actually decided to copy and paste these instead of drag it over, just because sometimes it changes the values. So I'm just copied one cell and I'm pasting it and everything. Now I'm going to select, make this a little bigger. I'm going to select where it says decimals to the thousandths. I'm selecting that column, not the whole thing, just the numbers. Going up here to the top and hitting general. And then my decimal values, I'm going to take them to the thousandths place. That's what the instructions said. And now for this last piece, I am going to report it as a percentage. All right, so that's pretty cool. If you take a multiple of 2, all the even numbers, you got a 50% probability of getting an even number. And I thought it was interesting that to get a multiple of 3, you have a 1/3% chance, a 33% chance of getting a sum of 3. All right, you guys, we have messed with some theoretical probability. We were looking here at these different charts of mathematically what would it mean to roll these dice and get these numbers out. Now we're going to explore some experiments and look at some empirical probabilities. All right, guys, so we finished our theoretical probability, and now we're going to look at some empirical probability. And we're going to use Excel to actually simulate some empirical probability experiments. So let's go to our document and see what's next. For empirical probability, we are going to start on the far right column and create a 2-column, 6-row set of random numbers. Let's just go to start with that. A 2 columns, 6 rows. So let me clear this out. All right, so right here I have created 2 columns. And if you just look at die 1 and die 2, these right here, die 1 and die 2, these are just the 2 columns I'm talking about. And here for the product and sum, that's moving forward. So let's just start here. I need 2 columns of 6 rows of random numbers. So die 1, die 2 are my 2 columns, and then I have 1, 2, 3, 4, 5, 6 rows. I'm going to put an equal sign here, and then type in RAND for random. A random number, you guys know we use a normal distribution generates random numbers. I can't remember if we've ever actually used random numbers here before, but we're actually not just looking for any old random number. We want a random number between 1 and 6 because we are going to simulate dice rolling. So a random number between 1 and 6, I am going to drag that command over to the right cell. I'm going to highlight those 2 cells and let that command well, I don't know why it won't work, but that's okay. Drag it all the way down here. All right, now I'm rolling a random number. This is 1 die being rolled, numbers 1 through 6, and the second die being rolled. And isn't that cool? Every time you press enter, or if you press the back key, back and forward, you can keep doing random rolls. Press back and forward, undo and redo up there, or you can double click the cell and press enter. So you can keep regenerating these, which is going to be way cool here in a minute. Every semester I always get a lot of oohs and ahs, and people, you know, are like, this is my favorite one because it's kind of fun. You'll see. So here now, the next set of my instructions on my document say to create a 3rd column for the sum and a 4th column for the product. So back on mine, I got a little mixed up here and created a 3rd column for my product and a 4th column for my sum, but hopefully that's okay with you guys. So what I'm going to do here is under my product, I'm going to put an equal sign, and now I want the product of my 2 dice. Whatever that roll was, I want the product of it. Now I want the product of the sum. Whatever the sum is, that number plus that number. Now I'm just going to select those 2 and bring that command all the way down. And now I have products and sums. All right, cool. What's next on the sheet? It says to duplicate the set of data. Where are we? Right here. Duplicate the set of data 3 more times and extend the new rows so that you have 4 columns. We want 6 rows, 60 rows, 600 rows, and a whopping 6,000 rolls. Yes, it rolls, rows. I know it takes a little bit of extra time to make 6,000 rows, but really it only takes about 1.5 minutes. So it seems like forever. Don't watch the kettle boil. Just bring it down without thinking about it. I'll show you what I mean. So here, let's go ahead and show you exactly how to do this. We just got done creating one. I know I've already created all these. I'm not going to create them on the video. What I do when I have to create long columns is I make my Excel as small as I can get it. I know how much you guys hate this. I might not make it quite that small, especially for this first one. I will for the 6,000, I'll make it as small as I can. So let's just, all I'm going to just really quick here, clear this content and take away my fill, and I could even take my borders off, but you know, whatever. I'm going to select my little chart I just made, my 6 rows, and Control Copy, Control Charlie, and then come over here and Control Victor. All right, now I have done that. So what I'll do now is select my bottom row here of the column I just pasted, and then grab that little right-hand corner of the last column, the bottom right-hand corner, and just drag it down. Now, when you guys are dragging this down, you can see over to the left that I got all the way down to 87. Well, I don't know, can you guys see that? See, I can see that I got all the way down to 87. Now, when you guys do your other columns, one of these, so my first one, My first one has 6 rows. My second one we just made has 60. And then my third one here has 600 and the fourth one has 6,000. So you guys are literally just going to do that same thing again. And when I make those really extra long ones, I literally make my Excel as small as I possibly can. And then it makes it drag a lot faster, and you just kind of hold it at the bottom and you'll be able to gauge, you know, how it's going. All right, let's move along. So now the next part of our instructions are telling us to create some histograms for this. So the instructions now say to create 4 11-bin histograms for the sum column and 4 6-bin histograms for the product column. So let's go ahead and see what that looks like. I'm going to start off with my first set of random numbers. Now, I'm going to make my screen smaller because I'm going to have a lot going on, and I'm actually going to move kind of quickly because you guys know how to use Excel now, so hopefully. I'm going to start off with creating 4 histograms for my sum columns. So those are, for me, are the peachy columns here because I had mixed them up. So my sum column, I am going to select that column and insert a histogram. And if you guys don't have a histogram, then you probably don't have Windows 16. So you'll have to use a different computer at work or at the library or a friend's computer. All right, so what I'm doing now is double clicking the x-axis on my histogram and going over to bin, number of bins, and changing that to 11. And then I am, let's see, this is the sum of 2 die 6 rows. Just label my charts. All right, now I am going to insert, you see my sum column over here now? All I'm going to do is click this very top where it says 4, put my cursor at the far right hand corner and double click all the way down. And then I am going to insert a histogram with double click the x-axis. Go to Access Options under the bar graph here and get number of bins and change that to 11. All right, now I know I need to move that over more, but first I'm going to collect the rest of these just to get them done. So I'm hitting this top cell, double click, it takes it all the way down, insert a histogram. And see how it gives me all those decimal values, but when I have an 11 bins, it gives me integers. That's what I want here. All right, so I'm double clicking my x-axis, nothing's happening, so I have to come over here and click on the bar graphs and access options, number of bins is 11. All right, no problem, it still gives me the decimal values, but that's perfectly fine. All right, now what? I have one more. I'm going to make this real small, and I'm just going to move these guys over. And of course, you guys are going to rename these charts, accordingly. Like this one is going to be named sum of 2 die, and here we had 60 rows. All right, this one is going to be the sum of 2 die, and we had 600 rows. All right, and then we get our last column here. So we'll click that all the way down and insert a histogram. Double click your axis down there and change your access option. This one has 22. That's why it looks so weird. Change that to 11. Beautiful. All right, now, what do we have here? This is going to be 6,000 rows. All right, so now I have these 4 bins. And you guys, whoops, now we are going to do the multiplication. I'm going to pause the video and get the multiplication ones in here just to save us a little time because it's done exactly the same way. So hold on just a second. All right, so I have my bins created here. Now let's see why we did this. So you see we have all these different distributions. Let's remember that that very top piece only used 6 data entries. The second graphs, the second histograms used 60 data entries. The third used 600 data entries, and the last one used 6,000 data entries. Do you guys remember when we used this applet here? Remember what happened when we just did 1 roll, and then we, keep doing 1 roll, and then we would do 10 rolls. And then remember what happened when we hit 10,000, well, we hit 100 rolls. And then when we hit 10,000 rolls, remember what happened? It looked like a normal distribution. Well, we have a law in mathematics that the more numbers you put into the data set, it will become normally distributed. So in other words, look at, this is just a perfect example. I'm going to go over here to my chart and press enter 1 time. And now I can go back up here and use my back and forward keys. See how I can keep changing that? So cool. So on this, look at the distributions. Look how much the distribution changes when I only have 6 data entries. Do you guys see that? It's completely, you can't get any information from that data. The way it's distributed, it keeps changing. We really don't have a good reading of what's going on because, it changes all different ways. Yeah, sometimes it looks like the bigger set, but sometimes it totally doesn't. But what happens when I get 600 rows and 6,000 rows? How much are those data sets changing? Well, you see where we have 600 rows, it changes somewhat. You see that down there? But look at the 6,000 rows. How much does that change? Even when the values change, they're still very normally distributed. So it really makes a big difference how many data entries you have to get your empirical information. Like the theoretical probability, we use mathematical probabilities. Empirical probabilities, we actually have to do experiments to calculate that. And the more experiments we do, or the more people we collect our data from, the more we can find out the true distribution of the data. All right, let's go back to our form and see what else we're supposed to do here. Label each chart and histogram accordingly. Please make sure all of your stuff's labeled. Change the histograms multiple times and observe the changes. Use the applet to explore. The applet is this thing here. Use the applet to explore the sum outcomes, and then relate the empirical probability demonstrated in the histograms and the applet to the theoretical probability demonstrated in the tables. Well, this is a good one. So you guys might have seen I had down here at the bottom of my Excel report, I had these things. Well, look at the bends. The bends. Sounds like I'm a scuba diver in bad shape, doesn't it? Look at the bends. And it's my name too. It's kind of funny. So look at the bins here on my histogram. Which bin has the most data entries? Well, this first one is rolling the number 1, the number 2, 3, 4. So number 7 has the most the greatest probability of getting rolled? Well, look at my chart here, my sum chart. How many cells have the number 7? 1, 2, 3, 4, 5, 6 cells have 7. The other 2 cells close to that are 6 and 8, and they each only have 5. You know, so the probability of rolling a 2 or a 12 is 1 in 36, where the probability of rolling a 7 is 6 out of 36. So you can see that the empirical probability, when enough data entries are used, does fulfill the shape of the theoretical probability. It gives out the same data. But, you know, like we said, if you guys went up here to your 6 data entries, look at that graph. You can't even, yikes, sorry, that's a little frustrating. So you can't really get the, you know, the sense of how your data is spread out. All right, so now the last thing that you guys are going to do is answer your 5 sentences, and everything that we've done here talks about these 5 sentences. I highly recommend you guys, when you're doing these Excel reports, I've noticed that a lot of you will tell me, Ms. Benzie, I finished my whole report, I just need to write my sentences. Guys, while you're watching this video and following along with Excel, have your 5 sentences written, not written, but just what they're, look, this is what I mean. You can't see my screen now, can you? So make sure that what I would do if I were you is I would write these down or print them out or whatever, define theoretical probability, define empirical, explain the difference. And then I would leave some space below there and make notes and write stuff down, because I say everything you need in these videos. So keep that in mind to work smart, not hard. All right, guys, we're ready to move on to scenario 2. You're doing an amazing job. Keep up the good work. I will see you in just a moment.